Hello everyone, welcome to the channel Top Gate. In this video, we'll see one more example of minimization of DFA. So this is a transition diagram of the DFA and this is the transition table for the same DFA. Now, if you analyze this closely, you can see in this one that there are no unreachable states. So just check it once that if you talk about Q1 has a path from Q0, so it is not an unreachable state. Q3 is the final state and there is a path. Q2 is the final state, there is a path. And Q5, there is a path you can see from Q2 to Q5. Q4 is the final state and there is a path. So all the states in this particular DFA are reachable. Therefore, we don't have to remove any of these states. But if you analyze this closely, you can see that there is one state which is reachable, but it is a dead state. Now, dead state is a state that is, if you reach onto that state, there will be no means to go back to the final state. Or you can say that a dead state will never take part in producing the final output of the machine. So if you see this one, we have this Q5. So this Q5 is not a final state, and if you reach on to Q5, there is no way so that I can go back to any of the final states. We have three final states, Q3, Q2 and Q4. So in this one, if you reach on to Q5, there is no path to either Q3 or Q2 or Q4. So Q5 is actually a dead state, but we don't have to remove it. We'll keep it in the DFA and then we'll see, we'll try to minimize it. But in the minimized DFA also, you'll see that you will get one dead state as we have in this one. Clear? So let's start doing this one. So first of all, I'll try to find out the zero equivalence or pi zero. Pi zero says that the number of states have to be divided into two sets. One is a set of final state, one is a set of non-final states. So let's just divide it. I have three final states in this one, that is Q2, Q3 and Q4. Clear? And the non-final states are Q1, Q0 and Q5. So I'll write Q0, Q1 and Q5. Let's call this as set number 1 and this one as set number 2. So now I'll make a table for set number 1 and then see if this set number 1 can be further divided or not. So let's make a table for set number 1. So I'll just write state here and then I'll write 0 and 1. Clear? So in state I have Q2, Q3 and Q4. So now let's check it for Q2. So for Q2 with 0, I have Q4. So Q4 belongs to set number 1. So I'll write set number 1 here. Similarly, Q21. So Q21 is Q5. Q5 belongs to set number 2. So I'll write set number 2 here. For Q3, I have Q4 and Q5. Q4 belongs to set number 1 and Q5 belongs to set number 2. Similarly for Q4, I have Q4 and Q5, again the same thing. So I'll simply write 1 and 2. So if you analyze this one, Q2, Q3, Q4 all are exactly similar. So therefore, we don't have to split this particular set. That means this becomes my final state, a combination of these three states in the minimized DFA. Clear? Now we'll move on to set number 2. So set number 2, again, I'll just make a table for set number 2. This is, I'll write state, then I'll write 0 and then 1. And in the states, I will write Q0, Q1 and Q5. So for Q0, we'll see we have Q1 and Q2. Q1 belongs to set number 2 and Q2 belongs to set number 1. So I'll write 1 here. Similarly for Q1 I have Q0 and Q3. Q0 is set number 2 and Q3 is set number 1. Again I'll write 1 here. Similarly for Q5 I have Q5 and Q5. Q5 belongs to set number 2. So set number 2 and set number 2. So you can see in this one that Q0 and Q1, they both are similar. Q5 is not like Q0 and Q1. Therefore, this set number 2 has to be divided. So therefore, I got my one more pi, that is one equivalence. So I'll just mention now my next pi, my next equivalence, that is pi 1. So in pi 1, I have Q2, Q3, Q4, that remains as it is. And then this set number 2 is further divided, that is I have got combination of Q2 and Q Q0 and Q1, and then Q5. Let's call this as set number 2 is broken. Let's call this as set number 3, set number 4, and this remains as it is, set number 1. So now I have set number 1, 3, and 4. Now I'll make a table for set number 1, and then I'll make a table for set number 3. So let's make a table for set number 1 again. So set number 1 again, I have Q2, Q3, and Q4. Now for sets, I will now refer to pi 1, not pi 0, because pi 0 is obsolete now. Set number 2 is gone. It has been split into set number 3 and set number 4. So now I'll look into pi 1, not in pi 0. So for Q2, I have Q4 and Q5. Q4 belongs to set number 1 and Q5 belongs to set number 4. Now Q3 again, Q4 and Q5. So Q4 is set number 1 and set number 4. Set number 1 and set number 4. Similarly for Q4, Q4 and Q5, Q4 is 1, Q5 is 4. So again it is similar, therefore set number 1 again need not to be splitted. Clear? So now I'll move on to set number 3. Set number 3 is Q0 and Q1. So again I'll write state and then 0 and then 1, and in state I will write Q0 and Q1. And Q0 for 0. Q0 for 0, I have Q1. Q1 belongs to set number 3. Set number 3. Okay. So Q0 1. Q0 1, I have Q2. Q2 belongs to set number 1. Correct. For Q1, Q0 and Q3. Q0 is 3 and this is 1. So 3, 1. So you can see Q0 and Q1 both are similar, therefore set number 3 need not to be splitted. Therefore this pi 1 becomes my final equivalence, and this first set number 3, set number 4, they becomes the final states of the minimized DFA. They become the states of the minimized DFA. Now let's make a table for the final minimized DFA. So I'll write state here, and then I'll write 0 and then 1. Okay, in the states I have 3 states, namely Q0, Q1. So I'll write Q0, Q1, and then I will write Q5, and then I'll write Q2, Q3, and Q4. So this is one state, this is one state, this is one state, and Q0 was the initial, so therefore I'll mention this Q0, Q1 as the initial state, and Q2, Q3, Q4 are the final state. So I have this one as the final state, so I'll just mark it as the final state. Okay, now go for Q0, Q1. So Q0, Q1. So Q0, Q1, you can see I have Q0, Q1. So Q0, Q1, it's available here. So I'll simply write Q0, Q1. With 1, you can see it is Q2, Q3. Q2, Q3 is not available. It is available in combination with Q2 and Q3 and Q4. So I'll write Q2, Q3, and Q4. Now go for Q5. For Q5, you can see it is Q5 and Q5. Q5 is available here, so I'll simply write Q5 and Q5 here. Now go for Q2, Q3, Q4. Q2, Q3, Q4, you can see it is Q4. Q4 is not available. It is available in combination with Q2 and Q3. So I'll simply write Q2, Q3, Q4. Similarly, Q5 and Q5. So Q5 I have, it is available, so I'll write Q5 here. So this becomes my final transition table for the minimized DFA. Now just make the transition diagram, the final DFA. So I have 3 states. I'll just make 3 states, Q0, Q1, that becomes my initial state, and then I have one more state, Q2, Q3, Q4, that becomes my final state, and one more state I have as Q5. From Q0, Q1 with 0, it is Q0, Q1, that is self loop of 0, and with 1 it is moving on to Q2, Q3, Q4. So I'll just make it as 1. From Q5, it is a self loop of 0 and 1, so therefore I'll just make a self loop of 0 and 1. From Q2, Q3, Q4, it is with 0 a self loop, that is a self loop here, and with 1 it is moving on to state Q5. So this is your final minimized DFA, and as we have discussed in the beginning, that in the minimized DFA, you will get a dead state. So therefore, you can see here that Q5 is acting as a dead state. That is, if you reach onto Q5, there is no way that I can go back to the final state. So you can say that Q5 is not taking part in producing the final output of the machine. So this is your minimized DFA. Thank you so much.